Good morning, students. DC 8501 Digital Communication. Here we see about delta modulation, that is Unit 2. Here the delta modulation is signaling rate and transmission channel bandwidth are required large in PCM system. So always the delta modulation we can say only 1 bit per symbol to transmissions modulation scheme. Okay, so here the delta modulation transmits only 1 bit per symbol. So present sample value is compared with the previous sample value to check the amplitude changes. Okay, here the step size is fixed. So difference between the input signal x of t and staircase approximated signal is obtained two levels. So one is the plus del and is the minus del. So now we see about delta modulation waveform. If the difference is positive, signal increased by step 1, right? So that is the transmitted bit is 1. If the difference is negative, the signal decreased by step 1, that is del. Here the transmitted bit is 0. So now we can see the calculation b of nts equal to plus del if x of nts greater than or equal to x bar of nts. So if we consider minus del if x of nts that is less than of x cap of nts. Here the b of nts equal to plus del, binary 1 is transmitted. b of nts equal to minus del, binary 0 is transmitted. So how we can calculate the error signal, that is E of nts equal to x of nts minus x cap of nts. Here the x of nts is the sampled signal of x of t, then x cap of nts equal to last sampled approximation. Here the dm waveform. Here the original signal is a m of t and the staircase approximation signal is a stepwise signal. So the difference between the step up and step down, here the del, right? So here the equal sampling period is ts. Then DM transmitter section. Here the original block diagram of the DM transmitter. This is the 1 bit quantizer. The summer in the accumulator adds quantizer output plus or minus del with the previous sample approximation. The present sample u of k ts equal to u of k minus 1 ts, that is plus or minus del. The previous sample approximation u of k minus 1 of ts is restored by the delaying one sample period ts. Here see the block diagram, sample input is available, then the error signal e of k ts. Here the 1 bit quantizer, that the input signal is moved to the 1 bit quantizer, that is directly moved to the delay section, that is u of k ts. So it is considered as a delay is a u of k minus 1 of ts, then get the output as x cap of kts. So finally we calculated difference between the original signal and for the output of the signal, that is xk of minus x cap of kts. So finally we get the e of kts. This is for the original DM transmitter section. Then finally we go for the DM receiver section. Here the just opposite for that. So here the accumulator generates the staircase approximated signal output and is delayed by one sampling period ts, that is a sampling time period. So it is then added to input signal. So if input is 1, add plus del step to the previous output. If input is 0, adds minus del step to the previous output. So after that accumulation process is directly moved to the low pass filter. Finally we get the output. So this is original process of the DM transmitter and the receiver junction. Thank you, students.